Every day, so many people put their queries related to multithreading, multiprocessing, parallel programming, synchronous, asynchronous, and some other. In this video, we are going to discuss concurrency and parallelism, what is the difference between multiprocessing and multithreading, and much more. As per control flow, programming is of two types, synchronous and asynchronous. In synchronous programming, suppose we have four types of requests, request 1, request 2, request 3 and request 4. So how we handle in synchronous programming, we will start the execution of request 1. Then as we can see here, four instructions here, request 1, after that request 2, after that request 3 and then request 4. So in the same sequence, these statements will get executed. So we'll start with the execution of request 1. After that we'll wait for the execution of request 1. When we'll get the response of request 1, we'll start the execution of request 2. Then again we'll wait for the execution of request 2, and after getting results for request 2, we'll start execution with request 3 and then again start the execution of further request 4. So in such a way, we execute multiple type of requests in synchronous programming. We have to follow a particular sequence in the statements are given in the program. Come to the synchronous programming. Again, suppose if we have four requests as we saw in synchronous programming. So in asynchronous programming, how we'll handle these four requests? We'll start the execution of request 1, but here we are not restricted with the sequence of given statements. That is, we are executing request 1. Here we are not waiting for the execution of request 1, but before getting completed of request 1, we'll start the execution of request 2. And in the similar way, start the execution of further request 3. Meanwhile, we get the result of request 1. So here we are getting response 1. After that, we'll start with the execution of request 4. We are getting the response of our executing request. Here response 3, response 4 and response 2. So this is the basic concept of synchronous and asynchronous programming. Now let's come to the concept of parallelism and concurrency. So parallelism and concurrency is nothing but these are also a form of synchronous and asynchronous programming. As we can say that parallelism is a form of synchronous programming and concurrency is a form of asynchronous programming. Let's understand what is parallelism. Parallelism is nothing but in parallelism, we are executing multiple tasks at the same time. As we can see here, we are executing request 1, request 2, request 3 and request 4 at the same time. Basically, parallelism runs on multi-core machine. Suppose it has four problems. These four problems obviously would be divided into multiple kind of instructions. So what happens in parallelism? Each problem runs on a specific processor, or we can say that a particular processor is dedicated to a specific problem. As we can see here that a first problem that has a specific kind of instructions run on a specific processor, second problem run on this processor, third and same as the fourth, right? So we can say that parallelism runs on a multi-core machines and it executes the task in a parallel way. Parallelism, parallel processing or parallel computing, at the root, these all refers to the same thing and is implemented by a multiprocessing system. As we saw that parallelism runs on multi-core machines, so we can say that it is implemented by multiprocessing systems. If we talk about the real world example of parallelism, then we can say that when we use our phone while charging, that is most of us have done in our life. So that is an example of parallelism, because in that case hand we are using our phone, so we can consider ourselves as a processor, and on the other hand charging cable is charging our phone. The things are done in a parallel way. So this is an example of parallelism. Let's come to the concurrency. What is concurrency? Concurrency is dealing with multiple tasks, but we are executing a single task at a time. In parallelism, we saw that we are executing multiple tasks at a time, but in concurrency, we are just dealing with multiple tasks but executing a single task at a time. We can understand it as, suppose we have request 4. So here at a time we are dealing with 4 requests, request 1, request 2, request 3 and request 4, but at a time we are executing only one request. As here we start the execution of request 1, then we jump to the request 4, again we jump to the request 2 and then request 3, because request 1 doesn't get completed yet. So we are coming back to the execution of request 1. So we can see here that we are dealing with multiple requests, we are dealing with 4 type of requests, but we are running a single request at a time. Told that parallelism runs on multi-core machine, on the other hand concurrency runs on a single core machine. Now in parallelism we have multiple processors and we are running multiple problems there. We are getting it as one problem on one processor, but here we are running multiple processes on a single core machine. So how would it work? By using context switching. As we start the execution of T1, after some time we start the execution of T2 process without getting completed of T1. So again after executing T2 for some time, we again starting the execution of T1 process. So this is basically working as a context switch. For some time T1 is getting executed, after that T2 is getting executed. Because the execution of T1 process doesn't get completed, so we are coming back to the execution of T1 process. So we can say that concurrency executes a task in an overlapping manner. Now how the concurrency is achieved? So concurrency is achieved by multithreading, where multiple parts of the same program runs as a thread, and multitasking. So basically concurrency is achieved by 2 ways, multithreading and multitasking. Multithreading, where multiple parts of the same program run as a thread, and multitasking, where multiple tasks are executed in an overlapping manner. So what is the difference between multithreading and multitasking? We'll see further in the video. Now if we talk about the real world example of concurrency, then a person who is cooking and washing clothes at the same time is an example of concurrency, because a person is dealing with 2 tasks, with cooking and washing, but at a particular moment a person is focused with a single task. Either he or she will cook or will wash his clothes. So this is the basic concept of parallelism and concurrency. Let's understand the difference between parallelism and concurrency. So parallelism is executing the multiple tasks at the same time simultaneously, but concurrency is dealing with multiple tasks but executing a single task at a time. Parallelism runs on multi-core machine, although concurrency runs on single core machine. In parallelism we execute the task in a parallel way, but in concurrency we execute the task in an overlapping manner. Parallelism, parallel processing or parallel computing, everything is implemented by multiprocessing system, but concurrency is achieved by 2 ways. First is multitasking and second is multithreading. If we talk about an example, then using phone while charging is an example of parallelism. If a person is cooking and washing his clothes at the same time, that is an example of concurrency. We saw that parallelism is a form of synchronous programming and concurrency is a form of asynchronous programming. Now according to parallelism and concurrency, there would be 4 possibilities that we could have. That is parallel with no concurrency, concurrent with no parallelism, concurrency with parallelism, neither concurrent nor parallel. So let's come to the first possibility, that is parallel with no concurrency. So what is it? At a time, if a system is running various tasks on multiple cores of CPU simultaneously, then we can say that it is a concept of parallel with no concurrency. If we talk about an example, then whenever we go to the supermarket, we saw multiple billing counters there. So what happens in that billing counter? In supermarkets, multiple billing counters are doing their own work. So basically, these multiple billing counters are providing an example of parallelism. Concurrent with no parallelism. Here application is dealing with multiple tasks but running only a single task at a time. As we told in your example that if you are cooking and washing utensils too, then this is an example of concurrency with no parallelism, because a single person is dedicated to multiple tasks, although at a time he is performing a single task at a time. Concurrency with parallelism. So an application is running various processes in a multi-core CPU by dividing a process to multiple tasks and run those tasks concurrently. Basically what happens here, that a system is using multi-core CPU on which we are running multiple processes. The process is further divided to the multiple part. So if we talk about an example, whenever we go some restaurant, there were number of cooks who were cooking food for us, and a single cook is not dedicated to a single task. Single cook is cutting vegetables, cooking food, or sometimes he is also serving food to the customers. So there would be number of cooks who are working there, and a single cook is performing various type of tasks concurrently. So this is an example of concurrency with parallelism. Next case, that is the neither concurrent nor parallel. Application is performing a single task at a time on a single core CPU in a sequential manner, that is called neither concurrent nor parallel. Because why it is not parallel? Because here we are working on a single core CPU and a single process is running here. That's why we are saying that it is not concurrent. Possibility could be a person who is traveling from Delhi to Bombay, because there is a single person, so the example could not be parallel, and he is traveling from Delhi to Bombay, so he have to follow a specific path that goes from Delhi to Bombay. He doesn't have any other possibility, or he cannot divide his journey to multiple parts. So that's why here we are saying that this is an example of neither concurrent nor parallel. While talking about concurrency, we saw that concurrency is achieved by multithreading and multitasking. Now we'll see what is the difference between multitasking and multithreading. So multithreading is nothing but it is an upgraded form of multitasking. In multitasking, system is performing multiple tasks and each task has its own memory space. But in multithreading, system is performing multiple threads of a single task. Basically, multitasking is dedicated to a complete process, but a multithreading is dedicated to the different part of a complete process. That's why here we are saying that multithreading is an upgraded form of multitasking. Each process contains own memory space, but in multithreading, a process is divided into multiple threads or multiple parts that runs as a thread, and these all threads share the same memory space. Multithreading is quite faster than multitasking, because in multithreading we are dividing the task between multiple threads. Obviously, if we are doing some work and it is taking 1 hour, it would be better that I will divide the work into multiple persons, and those persons can complete the work in 5 minutes. So the same concept applies here, that in multithreading we are dividing the process into multiple parts, so it would be faster than multitasking. In multitasking, processes run in an overlapping manner, while in multithreading, threads run in a time slice. So what is it saying? We told in multitasking we are running various number of processes that runs in an overlapping manner. Suppose we start with process P1, then again we are executing process P2. So in such way we are running various processes in an overlapping manner. But in multi-threads, the system decides an execution time of each thread, and according to that time slices, multiple threads runs. You can understand multitasking as an operating system. We are running multiple processes at the same time. We are able to open Chrome, we are able to work on MS Word, we can open text editor as well. At the same time, we can open media player and we can listen any song. In multithreading, we are working on MS Word. So while working on MS Word, multiple part of the program, multiple part of MS Words are running there. Their graphics is running, while typing keystroke events are running, grammar check process is also running. So we are working on a single process. It's an operating system. There are multiple parts of the process MS Word is running there. Now let's see the difference between multiprocessing and multithreading. So we saw that multiprocessing is nothing but here we are using more than one CPU, while multithreading runs on a single core machine. Because What is multithreading? Multithreading is used to achieve concurrency. Concurrency runs on single core machine. So that's why we can say that multithreading runs on a single core CPU. Many processes are being executed simultaneously in multiprocessing. How? By using multiple processors, right? While in multithreading, multiple threads of a single process is being executed. We saw that what is multithreading? In multithreading, we are running different parts of a single process by threads. So in multiprocessing, many processes are being executed, and in multithreading, multiple threads of a single process is being executed. In multiprocessing, each process has its own memory. Yes, because in multiprocessing we have various number of processes and each process has its own memory space. While in multithreading, because all the threads belong to the same process, so all the threads share the same memory space that is allocated to a specific process. We can understand multiprocessing with this type of diagram. In multiprocessing, we have number of processes P1, P2, P3, and each process has its own CPU and its own memory space. As we can see here, that we have three number of processes P1, P2, and P3, and each process contains each CPU and its own CPU and memory. While in multithreading, a complete process has its CPU and memory, and this process is divided in various parts that runs as a thread. So process is divided into three threads, T1, T2 and T3. That's all about synchronous and asynchronous programming, parallel and concurrency, multithreading, multitasking and multiprocessing. I hope all these concepts are now clear to you. Thank you.